The first thing I did was lay the strip of LEDs on the foam board. This, with the width of the foam board, dictated how wide the project was going to be. I then measured the whole of the board I had and divided the useful area by 4. Then I measured and marked those with a pencil and a ruler. Using a scalpel, I then cut the 4 sections into 4 uniform pieces. I thought about how the box was going to go together. Using hot glue would have been a very simple solution, but this was a prototyping exercise to see how this design looked. And using tabs would be useful because then I could transfer those tabs over to another material like laser cut wood. I measured from the side of the material to create the tabs. This is the thickness of the material. This will allow the tabs to interlock at 90 degrees. I then measured along and created notches. These sections would interconnect with each other. Following this, I cut them out with a scalpel. Changing your blade regularly helps when cutting through difficult material like foam board. Unfortunately, I had no spare blades to hand, so this was slightly tricky for me. Once I created one version, I used it as a template for the others. This creates a problem where you have compound errors where the mistakes you made on the first one are transferred onto the others. But on the other hand, it means that others will fit together nicely because they are keyed directly to that one you created. Once I'd cut 2 out, you could see they interconnect nicely. The gaps and tolerances aren't as tight as I would like, but this is just a prototype, so I'm not too worried about it. I then repeated this step 4 times to cover all of the 4 edges. Then I assembled the box using the tabs. Now onto the electronics. To hook up the LEDs, I used a USB breakout. This is because the LEDs are running at 5 volts. I stripped the 5 volt and ground wire and inserted them into the USB breakout board. The guide on the Adafruit website recommends using a capacitor to avoid current spikes. I didn't use it in this bit because I was being lazy as I was just prototyping. I then cut off the connector because I don't have a connector that joins with it. I then stripped the wire ready to connect to the microbit. I connected the black crocodile clip to the ground on the microbit and the yellow crocodile clip to pin 1. This is connected to the data pin on the LEDs. I then plugged it all in to test it. It was at this point I worked out that I had just killed the LED strip or the strip was already dead. I'd put the default NeoPixel code on the microbit, so it wasn't the code's problem. I then went through testing all of the components one by one. So I switched out the microbit and that didn't fix the problem. And I switched out the power bank and that didn't fix the problem. And I switched out the crocodile clips and that didn't fix the problem. What the problem was the LEDs. I don't know whether I just killed them using a power bank or whether they were already dead before I started the project. I then switched to a different project, one that I knew had working LEDs. It used the same wiring structure except this one had a capacitor in line between the power and the ground. This hopefully will prevent the current spike that potentially killed the last set of LEDs. I came back the next day and wired up the LEDs to the microbit, and it's great to see them light up. I then thought, how am I going to adapt my project to fit this shape of LEDs? The LEDs are currently taped onto an aluminium bar. This makes them stand upright about 1 meter in length. I tried putting the box on top that I just created. This looks good, but it doesn't cover the whole length of the 1 meter. It only covers about half of it. I then carried on with my plan, but for a vertical design instead of horizontal that I initially planned. So I printed out the letters I wanted and cut them out into squares. I then glued these letters onto the foam board. These will act as a template for me to cut out. Once the glue had set, I cut out the letters using a scalpel. This was incredibly tricky, and my scalpel skills aren't great. This would look much better if it was laser cut. Once all the letters had been cut out, I then reassembled the box and put it over the top of the LEDs. I'm really quite pleased with the result. It looks like it needs some internal diffusion as you can see the LEDs through the holes. It's currently running the rainbow default code. For the example I planned was to have it red, but as this is RGB LEDs you could have it whatever colour you like. It does show up in the daylight, obviously not under video lights, but it shows up quite well under house lights, but it looks best when it's in a dark room. Now onto the code. The heart of this project is the BBC microbit, so to create the code for them I'm using the BBC microbit's website. I'm using 2 microbits. One is to control it and the other is to run the LEDs. I'll cover both code here. First, you have to set up the radio group. I'm having the 2 microbits talk to each other with very simple commands, but I'm going to set up the radio group. You set radio set group. I tend to use radio group 50 for my projects, but if you're using multiple projects at the same time, they will conflict if they're all on the same radio group. So make different projects, different radio groups. This is the code for the microbit that runs the LEDs. When we receive a number from the other microbit, we want to turn on the LEDs. So we need on receive, receive number. By default, NeoPixels aren't included in the library. You have to go into Advanced Extensions, NeoPixels. Then they will appear in the library. You have to do this every time you start a new project that requires them. In the Start section, you need Set Strip, and then you need to define which pin you're connected to. So that's the pin the crocodile clip is clipped to, and how many LEDs are in your string. For me, it's pin 1 and 25 LEDs. When the BBC microbit receives a number, you want it to show the strip, and I'm going to set it to show it as red. After the microbit receives the number, I want to turn on the LEDs and make them red. I use strip show color red for this, and then after you send any command, you need to do strip show. This will then send the information to the LED strip. To have 2 commands, one to turn it on and one to turn it off, I've used an if statement. Then use a comparison of the equal sign. That way, if the number received equals the 1, then it turns it on. So then it's if received number equals 1, it turns the strip on. To add a second condition, you need to press the plus sign. This will then change it to if else and allow you to duplicate the first condition and bring it down. You need to change the number to 2. For the microbit that sends the information, it is a similar process. First, on start, you need to set the radio group to 50. Under Inputs menu, add on button A pressed. And in that, radio send number 1. And to turn it off, on button B pressed, send number 2. This corresponds to the numbers on the receiving microbit. To add the code to the microbit, save the files, then they will appear in your downloads folder, and then copy them onto the microbits. In this example, you can clearly see that when I press A on the microbit, it sends the number 1 to the other microbit which is connected to the LEDs, and then the LEDs turn red. When I press B on the microbit to send, it then sends the number 2, which the other microbit receives, and then turns the LEDs off. This is a very simple example of the send-receive function, but it is useful for this small example.